Hello everyone, my name is Shubh Patel. My SAP ID is 56. My batch is B4. I'm from third year of electronics. In this video, I'm going to show how to design a inverting Schmitt trigger and astable multivibrator to produce a sawtooth and ramp waveform using simulation tool LT-Spice. This is the circuit diagram of inverting Schmitt trigger. We have applied a sinusoidal voltage to the inverting input terminal, and at the non-inverting terminal the voltage applied will be the threshold voltage, which will be the combination of R1 and R2 resistors. So it will be R2 upon R1 plus R2 into V out. Basically, the Schmitt trigger is the logic input type circuit that provides hysteresis for two threshold voltages for rising and falling edges. So this is helpful when we have a noisy input signal and we have to obtain a square wave from the input signal. So this is the threshold voltage. V upper threshold voltage is the voltage where the output voltage, which was positive, immediately becomes negative, and when it crosses the V lower threshold voltage it becomes positive. And when the input is lower than the threshold voltage, the output will be positive. When it crosses the threshold voltage, the output will become negative. And when the V input signal crosses this lower threshold voltage, V output becomes positive. So basically the V out does not depend on V in, but it depends on the changing of the V threshold voltage. This was for 10 Hertz frequency. Now let's see for 1 kilohertz frequency. So as you can see, for 1 kilohertz frequency a proper square wave has achieved. So now let's run for 10 kilohertz frequency. So we can see that there is the distortion in the waveform, output waveform. So which is at frequency 10 kilohertz. Unlike comparator, it was low, very much lower frequency. At very much lower frequency, that is f is equal to 5 kilohertz in comparator, but we are having distortion at f is equal to 10 kilohertz in inverting Schmitt trigger. Now let's move to the PDF. So this is the schematic. This is the waveform for 50 Hertz. This is the waveform for 500 Hertz. This is for 1 kilohertz. And this is for 5 kilohertz. In comparator, we saw that the output got distorted in 5 kilohertz. But Schmitt trigger performed well at 5 kilohertz frequency, and it got distorted at 10 kilohertz. So it is useful than comparator. So let's move to the astable multivibrator. This is the basic circuit of astable multivibrator, which is called as free running circuit. Free running oscillator. So to get the square output waveform, the basic principle is to force the op-amp into the saturation, and as it is the oscillator, no input voltage is applied, and it basically depends on charging and discharging of the capacitor. And at non-inverting terminal we have threshold voltage, and we have two values of threshold voltage, which is plus beta Vset and minus beta Vset. And the capacitor starts charging to the plus beta Vset when the output is plus Vset, and it start discharging to the minus beta Vset when the output will be minus Vset. So now let's run. As you can see, the capacitor starts charging to plus beta Vset when the output is Vset, and it starts discharging when the output is minus Vset. The capacitor starts discharging to plus beta Vset when the output is plus Vset, and it starts discharging to minus beta Vset when the output is minus Vset. This is the basic principle of the astable multivibrator. Now we will see how to generate a triangular wave from the astable multivibrator circuit. For this we will use a combination of two Zener diode in this position. As we have seen, the output will be the square wave for the astable multivibrator, and we have clamped that to the Zener diode combination, and we have taken the values of this diode as values are same of these two diodes, so that the frequency of the triangular waveform produced after this will be similar to the square wave. So after this, the clamped square wave which will be produced after this will be given to this integrator to produce a triangular waveform. Now let's run. So we have to just focus on this blue and red color waveforms. This blue waveform which will be produced after this astable multivibrator, that is at this position. This blue waveform that is square waveform will be produced, and at this particular position, that is after integrator, this red waveform, which is the triangular waveform, will be produced. So the triangular waveform is basically produced due to the integrator circuit, and the frequency is similar to the frequency is same to the square waveform because of this combination of Zener diode. Now we will see how to generate a sawtooth waveform. So this is the sawtooth wave generator, and it will generate a sawtooth waveform with different offset time. This is due to the fact that the values of these two diodes is not similar, so the rise time and fall time will be different. And we have also used a potentiometer which is connected to the non-inverting terminal of this op-amp OP07, and if this value, that is R7, will be, if R7 will be greater than R6, then the value will be more towards VEE, and if vice versa, then the value will be more toward VCC. In this case, R6 is greater than R7. Now let's run. As you can see, the rise time and fall time, these two are almost equal because our values of diodes are almost same, and we have generated a sawtooth waveform from a square waveform using a potentiometer and the combination of these diodes. So that's all in this video.
My software